Hello everyone, this is Niharika from Sri Venkateswara College of Engineering. I am here with a new topic in operating system. Let us move on to our topic, access matrix. Let us learn what is access matrix. Access matrix is a security model of protection states. In the computer system, it is represented as a matrix. The access matrix is used to define the rights of each process executing in the domain with respect to each object. The rows of the matrix represents the domain and the columns represents these objects. Each cell of matrix represents set of access rights which are given to the processors of domain means each entry. That is, I comma j defines the set of operations that a process executing in a domain di can invoke an object oj. Let us move on to different types of rights. There are four different types of rights, that is read, write, execute and print. Read means it is a right given to the process in a domain which allows it to read the file. Write means the process in domain can write into the file. Execute, the process in domain can execute the file. The process in domain can access to the printer, that is print option. Then let us now understand how an access matrix works for the example given below. Then observation of the matrix. There are four domains and the four objects that are three files F1, F2 and F3 and one printer. A process executing in D1 can read files F1 and F3. The process executing in the domain 4 has same right as D1 but it can also write on file. Printer can be accessed by only one processor executing in the domain D2. The process executing in domain D3 has the right to read file F2 and execute the file F3. Let us move on to the mechanism of access matrix. The mechanism of access matrix consists of many policies and semantic properties. That is, especially, we must ensure that a process executing in domain Di can access only those objects that are specified in row I. Then policies of access matrix concerning protection involve which rights should be included in the I and j entry. We must also decide the domain in which each process executes. This policy is usually decided by the operating system. The users decide the content of the access matrix entries. Association between the domain and the process can be either static or dynamic. Access matrix provides a mechanism for defining the control for the association between the domain and the processes. Let us move on to an switch operation. When we switch a process from one domain to another domain, we execute a switch operation on an object. We can control domain switching by including domains among the objects of the access matrix. The processes should be able to switch from one domain to another domain, that is di to dj, if and only if a switch rights to given to a access I and j. This is explained by using some example that is in the next slide. According to the above matrix that is in the previous slide, a process executing in the domain D2 can switch to domain D3 and the D4. The process executing in D4 can switch to the D1 and the process executing in the D1 can switch to the D2. We can see this in this table given below. Let us move on to an implementation of access matrix in OS. As already decided, the access matrix in the operating system likely occurs a significant amount of memory and is very sparse. Therefore, it is a storage insufficient to directly implement an access matrix for access control. The access matrix can be subdivided into rows and columns to reduce the insufficiency. To increase efficiency, the columns and the rows can be collapsed by deleting null value. For widely used access matrix, implementation can be performed using this decomposition method, that is global table, capacity list for domains, access list for objects, lock and key method. Let us learn these all four conditions in this. Various methods used to implement the access matrix in OS. that is global table. The global table is the most basic and simplest implementation of access matrix in the operating system, which consists of a set of an ordered triple, that is domain, object, and write set. When an operation M is being executed on an object OJ within a domain DI, the global table searches for a triple domain, object, and write set, where M belongs to RK. If the triple is present, the operation can proceed to the continue, or else a condition of an exception is thrown. There are various drawbacks to this implementation. The main drawback of the global table implementation is that because the table is sometimes too large, it cannot be stored in the main memory. That's why the input and the output are required additionally. Then let us move on to the second, that is access list. In the access list method, the access matrix in OS is divided into columns, that is column wise decomposition. When an operation M is being executed on an object OJ within domain DI, we search for an entry domain and the write set. That is M belongs to RK in the access list for object OJ. If the triple is present, the operations can proceed to continue, or else we can check the initial set. If M is included in the default set, access is allowed. Otherwise, the access is denied and an exception is arised. Let us see the third one, that is capability list. In the access matrix in the operating system, the capability list is a collection of objects and the operations that can be performed on them. The objects here is specified by a physical name called a capability. In this method, we can associate each row with the domain instead of connecting to a column by. Access matrix to the objects has an access list. Let us move on to the last mechanism, that is lock and key mechanism. It is a comparison between the capability list and the access list. Every domain has a distinct bit pattern called keys, and every object has a distinct bit pattern called locks. Only if a domain's key matches one of the locks of an object, a process can access it. In simple words, when a process running in a specific domain DI tries to access an object OJ, then the key of this DI must match with the lock of that OJ. Then only an object can be accessed. The operating system should handle the keys and locks in such a way that any authorized access should not be allowed on them. You could see an example here given in the flowchart. Thank you for watching my video.